can technology help facilitate the integration of renewables onto the network?
So I think it's a great question and a great challenge because, the grid was not originally designed for renewables. If, for example, by the original design, if I need more energy or higher capacity in London, I would probably generate it very close to London, either by coal in the past or gas or nuclear. But right now, renewables is all about generating energy where it is. So wind in London probably is not a great idea. Probably I need to get it somewhere in the British Northern Sea, an offshore farm. I need to transport it over very long distances. I need to deal suddenly with a lot of small sources, which are by design are fluctuated and unstable. And here technology can help because the grid, luckily, was designed with a very high margins. And why it was designed with high margins? One of the answers is that when you don't have data, you need high margins. Now that we have data, we can keep reliability as it is, maybe improve it, but reducing the margin, therefore generating more from the grid. I think one of the hot example of it's dynamic line rating. I would like to, people know today that I can extract much more from the grid without doing anything, like maybe 50% more, but it's not all the time. It's depending on environmental condition, on the temperature, on the wind. So if I would like to be brave enough to extract 50% more from the grid, I need to measure it precisely. I need a very reliable data, and I need that the data would be from everywhere all the time, because I'm looking at limiters that may risk the grid. So this is just one of the examples of technology pushing renewables energy into the grid.
I think that's a very good point, because obviously in the UK we have a significant challenge. Much, if not the majority, the vast majority of our wind energy is in the north of the country, whereas the significant demand is very much towards the south of the country. So having a more effective way of understanding what is the true capacity limits of the lines up and down the country on any particular day in any particular weather could, as you say, increase the capacity by maybe up to 50% in that area. How can energy operators design strategies with scale up in mind?
Scalability is a very important factor. I think that we are speaking about new technology. We're speaking about how to generate new values to the grid. And I think that one of the most important parameters is scalability, because we can do great pilots over few towers, get great results, but eventually, if you would like to implement it, it should be implemented from few towers to thousands or tens of thousands of towers. So this is like a huge scale, and scalability should be done by design. I can give just one example, is that when we start to develop our approach to transmission line monitoring, scalability was probably the most important feature. And we said that in order to be scalable, and what scalability is? Scalability is to be cost effective when you scale up, but also the ramp up time. How fast I can deploy a solution. If I can deploy it over a decade, probably it's not very scalable. And we said that if we can do monitoring without sensors, we can do a sensor-free monitoring, that will be very scalable, because most of the time it's like deploying those new hardware along the grid. And the question is how you do it without sensors. And luckily, what found out is that we have sensors along the grid.
So just extracting that value out of assets that are already
Exactly,
there.
absolutely. You have an asset that was designed to generate value in telecommunication. You can generate new value out of it in monitoring.
So how do businesses sort of extract this investment? How can they optimize the value for their businesses and from the services they provide?
Yeah, I think that if you're doing such a jump, such a big step ahead, you would like to optimize the value. And I think that the value starts with the fact that you need to collect vast amount of data from all the grid, all the time, very versatile data. Once you're ready, you need to understand that these steps is not a solution for dynamic line rating. It's not a solution for wildfire detection. It's not a solution for predictive maintenance. To optimize it, you need to understand that it's a solution for everything. You need to take it a step back and generate values across the board, from resilience to maintenance to predictive maintenance to reliability and so on.
Little like the digital twins we were talking about
Exactly,
earlier.
quite similar.